All right, so just so you know, this is 8th period. I'm just recording the end here so that everyone who missed class gets the whole thing. All right, so this is group 18, and these are called the whats. They have 8 valence electrons. Check. What is the name of this group? The noble gases. Check. They are unreactive. Check. Ooh, so do they have a high or a low melting point? Ooh, we've got high, low, low, low. All right, let me give you something to think about to help you with this. All right, my little Lamborghini is made out of metal. What would you have to do to get this metal to melt? Yeah, to melt into a liquid, we'd have to heat it up to a really high temperature. And then if you wanted to turn this metal into a gas, you'd have to heat it up even more, right? So this one has a very high melting point, a very high boiling point. And so if something like the air or a noble gas or a chlorine gas is a gas at room temperature, that must mean that it melted at a very low temperature in order to become a liquid, and then the liquid had to boil at a very low temperature to become a gas. So they are very low melting points. What about number 3? Are they volatile or not? And volatile is an interesting word because it means something different in science than it does in real life. So in science, it means that it easily turns into a gas. It easily evaporates, excuse me, at normal temperatures. So like at temperatures of the room here. And what does volatile mean like in English? What's the definition for like non-scientific?
To evaporate at normal temperatures.
Yep, that's the definition for scientific. What's the definition for just regular English? Like if you have a volatile situation, what does that mean? All right, so if you are just have like a volatile situation, regular real world, that is something that's going to change rapidly and unpredictably, especially for the worse. So if you get into a bad situation that is very volatile, then that's not the best situation to be in. But that doesn't mean in chemistry, just because something's volatile doesn't mean it's going to be highly reactive. Those are different things. It just means it's going to evaporate really, really quickly. And something has happened to my chat. Okay, my chat is back. I was really confused as to where my chat went. And I don't know, like when I have it pinned, my chat is wrong. When I open it up, then it's good. But anyway, so if you're watching the video, you aren't going to be able to see the chat. Oh well. So the noble gases, yes, they are volatile. They easily become a gas at room temperature. There's some other things you might run across in everyday life like that evaporate really quickly, like nail polish remover, paint thinner. Well, the way I'm recording this, it's only recording my screen, and I have popped out the chat so I can see it. And I popped out the names so that people couldn't see them on the recording. Interesting. Okay, let's move on. Let's see, valence electrons are 8. I want to make sure and get to everything here. All right, which nonmetal is the most reactive? Which nonmetal do you think is the most reactive? All right, so we've got an F. Where is F and Rn? F is right there. Fluorine. Where is Rn? All right, maybe you remember from yesterday, I talked about the 2 Fs in the corner, and we had, remember, francium was the most reactive metal. The other corner, fluorine, is going to be the most reactive non-metal. So up in the corner, not Rn. Okay, so reactivity. As you go down a group, what happens to the reactivity of the non-metals, knowing that fluorine is most reactive? Yeah, fluorine's the most reactive. It can only go one way. It's going to decrease as you go down. You can see that non-metals are all yellow here. And then, of course, the blue ones are the noble gases. So increasing reactivity, increasingly reactive as you go up, decreasing reactivity as you go down. Both on there. And from left to right, no typo on this one today. Let's see, we've got one person saying it increases from left to right. What do the rest of you guys think about this one? All right, we've got an increase, decrease, decrease. Remember, fluorine is the most reactive. So as you go from left to right to get over to fluorine, right, F is going to be your guide. Exactly, Ace. Let fluorine be your guide with the nonmetals, most reactive, and francium will be your guide when you're thinking about the most reactive metal. So as it goes across, it increases in reactivity of the nonmetal, except, of course, for those noble gases over there that are completely unreactive. Whew. And that brings us to the end. Here's my contact information and my quote from Nelson Mandela, so that you can change the world. And Zuleika, I'm sure that by the time we get to the interim, this is not going to be confusing. That's going to be my goal, is to make sure you do not go into that interim with any confusion. All right, so thanks guys for coming in.